Hello everyone. So today we will be learning theory of computation. So let us see what is actually theory of computation. Theory of computation is also known as automata theory. So automata is nothing but a Greek word where it means self reactions, where it is basically a theoretical branch of computer science and mathematics. It is a combo of both computer science and mathematics, and it mainly deals with the logic of computation with respect to simple machines, which are called as automata. And now we'll see the basic terminologies used in automata theory. Okay, so first one would be set. A set is nothing but a well defined collection of different objects. Okay, so set is actually denoted as, in terms of every set, that is each member of a set is written within the curly braces. So all the set will be represented in terms of capital A, B, C and so on, and the members will be denoted in the form of small letter A, B and C and so on. Okay, so set is a well defined collection of objects, and each individual object of a set is considered as members, or the called as members, or the elements of a set. Okay, so next step would be subset. A subset is nothing but where, let us assume that A and B are two sets. Okay, so if every element of set A is present in set B, then A is called as a subset of B. So let us assume that A has A, B and C as members, and B has A, B, C, D, E. Okay, so now we can see the elements which is present in A is also present in the set B. So we can say that A is a subset of B. So even in set, if any element is, for example, let's say A is a set which consists of A, B and C. So here we can say that element A belongs to set A. If in case A is not present in set A, then we can say that A does not belongs to A. Equal set is nothing but if two sets A and B has same number of elements and same type of elements, then we can say that A is equal to B. That is, set A is equal to set B. Empty set or null set. Empty set is nothing but when any set is of no members or no elements or no objects, then it gets considered as empty set. It can be represented in terms of curly braces just as it is without entering any elements, or fine. Okay, then power set is nothing but the set of subset of all, the collection of subset of all the elements of a particular set is considered as power set. It is represented 2 power A, where for example if we consider A as a set with these two elements, then combo of all the possible combinations of A and B is what we call it as power set. So now let's see what and all is there. Possibly a set which has only A and B's is a combination of all. First an empty set and just taking one element, then another element, then combo of both is the power set. All the combinations of a particular set is what we call it as power set. Then operations on set. Union is represented in terms of like this. So if A and B are two sets, then we can say that A union B. Here it is represented as X is an element where X belongs to A. That is element X, where element X belongs to A, or element X belongs to B, where all the elements present in A and B are written when A union B is specified without any repetition of the same element. Now intersection. Intersection is written as A intersection B equal to X. It's an element which is present in A and it elements present belongs to B, where only the common elements of A and B set is taken into consideration when it comes to intersection. Difference A difference B, that is X is an element where element X belongs to set A, or elements does not belongs to set B, that is the elements which are present in set A does not belongs to set B. This is what the difference mean. Next, terms in finite automata. Before going into the definition of finite automata, let's just go through the basic elements. Symbol. A symbol is nothing but an abstract entity. It is an abstract entity. Next, alphabet. Alphabet is nothing but a alphabet or a character set is a collection of symbols. Character set, alphabet or character set, both means the same. It is a collection of symbols. Where it is, where each individual element is called as a symbol, it is a collection of all the symbols is what we consider as alphabet. String or word. It is string is basically a sequence of symbols from the alphabet summation. So alphabet is represented in terms of summation. Okay, string is a sequence of symbols from alphabet. Okay, then length of a string is nothing but the total number of symbols present in a string. So length of a string is represented by taking 2 bars. Empty string is nothing but it is a string of length 0. Length 0. Next, so here operations on string. Concatenation. Concatenation is nothing but combination or combining two different strings as one. For example, if X is equal to computer and Y is equal to science. So concatenation of both these strings is what we consider as concatenation. So it is represented in terms of dot. So X dot Y equal to the length of X plus the length of Y. So this holds good. Now the concatenated string would be computer science. Computer science. So this is what the concatenation means. Prefix of S is nothing but, let us assume that S is equal to A, B, C. So this can be represented as phi, then A, then AB, then ABC. Whereas suffix of S, it can be like, even let us assume that it is also same. So this can be represented as phi, that is empty string, then C, then CB, then CBA. It can be, the places can be changed according to us. Language. A language is nothing but it is a set of strings formed from some specific alphabet summation. The language L is simply a subset which can be represented like this. Sorry, it is not visible. So language L is a subset of clean star. A clean star, it actually denotes the set of all strings. So set of all strings is nothing but alphabets. So this is for today. So today we have learnt theory of computation, meaning which is basically automata theory. It's a theoretical branch of computer science and mathematics. It deeply deals with logic of computation and with respect to simple machines, that is automata. Basic terminology is set. It is actually a well-defined finite number of objects. Next, subset. Subset is nothing but the let us assume that A and B are two sets. If the elements presents The elements which are present in set A is also elements which is present in B, then we can say that A is a subset of B. Equal set, when the elements of both A and B are equal, then they are considered as equal set. It is written like this. Then empty set or null set, when as a set with no member or objects, then it is considered as empty set. Power set, where possible combinations of all the elements of particular set, then we can consider it as power set. Then operations on sets. Sets operations are union, intersection and difference. Union means all the elements has to be written without any repetition. Intersection is writing all the common elements of two sets. Difference is the elements present in first set should not be present in second set. That's what we consider difference. Then terms used in finite automata. Today we will only know about the basic terminology. Tomorrow we will learn about the finite automata. Definition. Symbol is actually it is an abstract element like 1, 2, 3 or ABC, so on. Alphabet is actually a character set. It is a finite non-empty set of strings. String or a word is a sequence of symbols of alphabet, that is summation. Then length of a string is nothing but the total number of symbols present in a string. Then empty string is nothing but it is a string of length 0. Next, then the operations on string. The operations are concatenation, prefix of s, suffix of s, language L. Concatenation is nothing but combining two strings. So prefix of s is nothing but writing s as possible leading symbols of s is what we consider as prefix of s. Suffix of s is nothing but any number of trailing symbols of s, that is from backward, whereas prefixes is forward, whereas suffix is backwards. Language. In theory of computation, language is a set of strings formed from some specific alphabet summation, where language L is a subset of clean star. This symbol is said as clean star alphabets. Okay. A clean star represents set of all strings. Set of all strings is nothing but alphabets. So this is for today's video.